So let me show you how I configure the Vive track space here with the fans around the area. So I've got a fan there. There's a little fan up there, and I've got a heat lamp right here. And you know, if I'm going to simulate environmental conditions, the computer has to know basically like where these are within the three-dimensional track space in the real world, so that it can trigger them, and also like which plug they're plugged into. I've got each one of these effects hooked up on this type of box right here, and this thing is like a power strip that's got a computer in it, so it listens over the network here, and you can daisy chain like a whole bunch of these together. It works kind of like an Internet of Things device where the signals propagate through all of these, and if it's responsive to a message, it'll go ahead and control the fan or heat lamp or whatever it needs to trigger. But Unity basically has full control of the way it's set up. So I've got one mounted up here on the wall, and all these effects devices are all hooked up to it. And here on the computer, I'm going to run a tool that I made. So this tool basically allows me to sort of configure the electronics and the spatial arrangement of all these things here. So I'm going to go ahead and clear this config I've got right now. So I'm going to reset everything, so then you guys can see me do a fresh one. And basically everything's the way you would expect. I got the handsets, but then I've got one of these boxes here floating in space. And if I click configure, it gives me basically a bunch of buttons for each channel. And if I had more than one box hooked up, they would propagate kind of like right next to one another, and I could configure them all. Of course, right here I can turn all channels on, and everything turns on, and then all channels off. So you're kind of controlling the high voltage duty cycles of all of these devices from inside of VR, which is a really cool thing. It's called cyber physical is the concept academically. I really like cyber physical type things. So if I hit channel 1, the video pass-through turns on the Vive, and that's just to help me because I can feel the fan that turned on behind me that's hooked up to channel 1. But I need to now tell the computer that it's a fan, first of all. So I've got a menu here on my left hand, and then on my right hand I can choose that it's a fan, and that pops up right there, and I just sort of drag right to the fan itself. Okay, there you go. Scale that up so you can see that. It doesn't have to be exact, and that's how I basically teach the computer where stuff is. I know channel 4 is a heat lamp, so let me do that since that's different. And so there's the heat lamp, and there we go. And then I say done, finished. And I'll finish the rest later. But over here on the computer, I'll show you guys kind of like what it's doing. So behind the scenes, so like over here on the computer, it's producing this JSON file, and this JSON file basically lives on the computer and works between all applications. So you can write multiple simulation apps. So you can see there's my fan that I configured. It's a type fan, the position, the rotation and orientation of it, and then the heat lamp there that we configured. So that's the config file that lives kind of just persistent on this machine. So like by you using VR, just the handsets and the headset, you can easily kind of configure up different arrangements. And if you had like other devices, like say humidifiers or solenoid valves, there's another type that I didn't show that you can choose, and like you can do custom packet commands to that if necessary, and hook up like maybe it's an Arduino and you're communicating to it through the network. So there's all kinds of options, but if you guys want to get a hold of one of these and try it out, you can contact me and I can give you the instructions, or it's on IndieGoGo. I'll try to put the link on this video, but I call it cy.PIPES, and you can kind of think of it as like a Unity controlled power strip.